Hi everyone, welcome to the optometriosis. In this video, we see the automated refractometer. We all know that the automated refractometer is also known as AR. It is an objective method used to measure the refractive error. In this video, we can see how the AR machine works and what are the types of AR. Let's learn with me. The basic principle of AR is retinoscopy and Badal optometer. Virtually all AR have a Badal optometer within the measuring head. The Badal lens system has two main advantages. First of all, the linear relationship between the distance of Badal lens to the eye and ocular refraction within the meridian being measured. Secondly, with the Badal lens, the magnification of the target remains constant irrespective of the position of the Badal lens. Now, we see detail about the basic principle of the automated refractometer. Infrared light is collimated. Collimated means the infinity light rays coming and it gives a parallel line and passes through a rectangular mask housed in a rotating drum. The light passes through a beam splitter to the optometer system. This system moves laterally to find the optimal focus of the split on the retina. Optimal focus is achieved from the light sensor and the polarized beam splitter effectively removes reflected light from the cornea, whereas the slit image on the retina passes through the polarized beam splitter. The system measures at least 3 meridians of the eye in order to derive the refractive power of the eye using the sine squared function. And the sine squared function of ocular astigmatism describes the variation of meridional astigmatic power. Thus, for any given prescription, spherical, cylindrical into theta, the power along any given meridian is given by the formula spherical plus cylindrical into sine 2 theta. Now you see this picture. It illustrates the sine squared function for the prescription is plus 2 and minus 5 into 90 degree. AR only needs to calculate the power at 3 chosen meridians in order to calculate the spherocylindrical prescription using sine squared function. Basically, the 3 power measurements at the 3 respective meridians provide 3 points on the sine squared function graph. From this, the rest of the curve can be extrapolated in order to calculate the maximum power values, that is the principal focal planes. Fundamentally, there are 3 types of AR which derive objective refraction by image quality analysis, Scheiner's double pinhole refraction and retinoscopy. Each one will now be discussed in detail. First, image quality. This method is not used very much in modern days. It was originally used in dioptrum AR. Now just we recall the basic design of AR in shortly. Here the optimal position of the Badal optometer lens was determined by the output signal of the light sensor. The rotating drum effectively produced light and dark alternative targets. The light sensor matches the intensity profile of the incoming light from the eye to the light intensity pattern from the rotating slit drum. This figure shows the image quality analysis determines the optical position of Badal optometer lens. A low intensity profile tells the AR that the Badal lens is not in the correct position to correct the meridional power. You see this picture. When the higher intensity profile reaches the peak, the Badal optometer reading is taken to signify the power of the meridian being measured. Once this is performed for 3 meridians, the sine squared function is used to derive the spherocylindrical prescription. And second type, Scheiner's double pinhole refraction. In general, 2 LEDs are imaged to the pupillary plane. These effectively act as a modified Scheiner's pinhole by virtue of the narrow pencil of light produced by the small aperture pinhole located at the focal point of the object lens. You see this picture? In this figure, a detailed analysis of Scheiner's double pinhole refraction can be discussed. Once the LED are imaged in the pupillary plane, ocular refraction leads to doubling of the LEDs if refractive error is present. After refraction, the retinal image of the LED reflects from the retina back out of the eye. However, light emanating from the eye is again reflected by a semi-silvered mirror to a dual photodetector. In order to differentiate between crossed and uncrossed doubling, the LED flicker alternatively at a high frequency. The dual photodetector image is designed to image only on of the two LEDs in each off. As a result, crossed and uncrossed diplopia can be detected. According to the type of diplopia, as the LED system moved back and forth, the separation of the diplopic images varies on the photodetector. When the retinal image is single, a single LED image is centered over both photodetector. The LED position corresponds to the refractive error in the meridian. In the case of astigmatism, LEDs are used and the power perpendicular to the meridian under test is measured. It is apparent from that alignment of the photodetector is important. Basically, it is important that both the patient fixation and instrument axis are coaxial. If this condition is not met, effectively the objective refraction is conducted from an off-axis point and this leads to error. And third type is retinoscopy. In retinoscopy, some AR use infrared video refraction. A grating or slit is produced by a rotating drum. Similar principle of retinoscopy are used where the speed of reflux is used as an indicator of the patient refraction. The optical configuration was originally described by Foucault and was used to test the surface quality of mirror. It is now better known as a knife test where the slit or knife as it was originally called was produced using a pair of blades side by side. The basic optical construction is shown in this picture. The slit is used to determine the refractive power of the eye. The speed and direction of the movement of the reflex is detected by photodetectors and computed to derive the meridional power. Now, this picture shows that configuration of the detectors. The vertical slit calculates the refraction of the vertical meridian. The system detects that the vertical meridian is measured by the way each detector senses the slit as it passes over the pupil. The time differences from the slit reaching each of the detector allows the AR to detect the meridian under investigation. The oblique slit will likewise initiates a different time dependent responses from the detectors and thus they derive the power within the oblique meridian. Once the optimum movement is derived corresponding to neutralization in the meridian, the diopter value is plotted on the sine squared function to derive the spherocylindrical refraction. And that's all. Today we learned about how the AR machine works and types of AR. Let's meet you in next video. Thank you.